Hi and welcome to Demystifying Math. In this lesson we're going to be discussing geometric series. Let's start off with geometric sequences. You know that a sequence is geometric if there is a constant ratio. In other words, if you can take one term of the sequence and multiply it by a number to get the next term of the sequence, and that number needs to be constant or the same number each time. Let's look at this sequence that we have here. We have the numbers 2, 8, 32, 128, and so on. If I multiply 2 by 4, I get 8. 8 by 4, I get 32. 32 times 4 gives me 128, and that will produce all the terms of the sequence. In this case, my constant ratio is 4. We can very easily find a formula for a geometric sequence, by using the formula g times r to the n minus 1. In this case, g is our first term of the sequence, and r is our constant ratio. For this example, g is 2 and r is 4, so we have the formula 2 times 4 to the n minus 1. Let's go ahead and use this formula to find one of the terms of the sequence. Suppose that we wanted to find the fourth term. Well, in this case, we already know that it's going to be 128. But if we were to use the formula for that, we would just plug in a 4 for n. That would mean that we would have 4 to the third, which is 64, times 2, which gives us the 128. The formulas are more convenient to use if you're looking for terms of the sequence further down. For instance, you wanted to find the 25th term. You wouldn't want to have to write out 25 terms of the sequence to get there. All you would have to do is plug in a 25 for n and evaluate the formula. Alright, but in this video series we want to focus on series, not sequences. A series is really just the sum of the terms of the sequence. So for this particular problem, we're going to add together the terms. So our first term is just 2. Our first two terms add up to 10. Our first three terms come out to 42. The sum of the first four terms is 170, and so on. So this list of numbers, 2, 10, 42, 170, and so on, are the list of numbers in the series for this geometric sequence. This is often called a list of partial sums. Let's look at another example. Suppose that we were given the sequence 100, 25, 25 fourths, and so on. What you could quickly figure out is that we're dividing by 4 each time to get the next term of the sequence. Well, if we're dividing by 4, it's the same as multiplying by 1/4, so my constant ratio is 1/4. My first term of the sequence is 100, so the formula is 100 times 1/4 to the n minus 1. Let's go ahead and look at our series for this particular sequence. So we're going to write out a list of our partial sums. The first term is 100. The sum of the first two terms is 125. The sum of the first three terms is 525 over 4. So that gives us our series. Now what we want to do is find a formula for the geometric series, or the sum of the geometric sequence. So we have this S representing our sum. G is our first term of the sequence. Then we would add it to the second term, and we get the second term by multiplying the first term by our constant ratio. Then we're going to multiply our second term by our constant ratio again to get GR squared. And then we would have GR cubed for our fourth term. And then add them all together to get our sequence, our sum of our sequence, or our series. Alright, so now what we're going to do is multiply that formula by r. So we get this new formula. All I did was take each term and multiply it by r. GR became GR squared multiplied by r gave us GR to the third. GR to the n minus 1 times r gives us GR to the n. Now I'm going to subtract those two formulas. Well, what you should notice is that on the right side, a lot of the terms are going to cancel out when we subtract. And all we're going to be left with is the first and the last. So we have this formula. Now I'm going to factor it and isolate S. So I have this formula for my sum. G times 1 minus r to the n over 1 minus r. Now we can also write this in summation notation. With the first one we have I equals 1 to n of g times r to the I minus 1. Now you've been seeing this as g times r to the n minus 1, but it is going to be n minus 1 when we plug in the n here. And the second one is if you start your sequence at 0 instead of 1. We just made a little adjustment with the exponent. And that's going to equal our sum formula. So this is going to give us a sum of n terms. Okay, let's use that formula to help us find the sum of the first 6 terms of a geometric sequence. We have this sequence 5, 10, 20, 40, 80, 160. So we want to find the sum. First thing that we need to figure out is what is our constant ratio. So we're multiplying by 2 each time to get the next term. So r is 2 and g is 5. Plugging into our formula, we have 1 minus 2 to the 6th over 1 minus 2 times 5. So that gives us 315. You can verify that pretty easily by adding up these 6 terms, and you should get 315. Let's go ahead and find the sum of the first 15 terms. Okay, so we're going to replace 6 with 15, and now we have 163,835. Notice that this list of numbers is growing very fast. Let's try another example. Let's find the sum of the first 15 terms of this geometric series. We're going from 28 to 14 to 7 to 7 halves. And you can see pretty quickly that in this case my constant ratio is 1 half. My first term is 28. So g is 28, r is 1 half, and we're going to go ahead and plug that into our formula. So I get a number really close to 56 for my first 15 terms. Notice that the terms of this sequence are getting smaller and smaller each time, so we're adding less and less. Let's look what happens when we try to find the sum of the first 40 terms. We actually come out to 56, which isn't very much more than what we had here, and that's because these numbers after the 15th term are so small they're not making much of a difference here, and we're getting the number 56. Okay, the next video in this series will be more on geometric series, so look for that coming up. And if you have any questions, contact me at demystifyingmath@comcast.net.